Now we know the difference between combinational and sequential circuit. In case of combinational circuit, the outputs depend on the present inputs only, but in case of sequential circuit, the outputs depend on the present as well as previous inputs and also previous outputs. Some examples of sequential circuit can be latch, flip-flop, etc. In the previous lecture, we talked about different types of latches, and there we used clock signal. But if there is no clock signal in the latch, the circuit will become simpler. So if we use clock signal in latch, the output will depend on the level of the clock signal, and for flip-flop, the output will depend on the positive or negative edge of the clock signal. Let's see what do I mean. So in this lecture, we will talk about flip-flop, and we will particularly see how the flip-flop works. In case of latch, the output will depend on the positive level or the negative level of the clock signal. So these are the positive levels and these are the negative levels. And in case of flip-flop, the output will depend on either the positive edge or the negative edge of the clock signal. So these are the positive edges where the voltage rises from 0 to 1 or negative to positive, and these are the negative edges where the voltage drops from positive to negative. So in case of flip-flop, the output will depend either the positive edges or the negative edges. Let's see the output of D latch in timing diagram. So here we have the input D, clock signal E, and depending on the combination of D and E, we will get the output Q. So we are assuming that initially our Q was 0. So from this position to this position, our clock signal is 0, and we know for D latch, when our clock signal is 0, we will get the previous output. So as our previous output is 0, so from this position to this position, we will get the output as 0. Now from this position to this position, our clock signal is 1, and when our clock signal is 1, we will get the output whatever D is. So from this position to this position, we have our D as 0, so we will get 0 in the output. From this position to this position, our clock signal is 1 and our D is also 1, so we will get the output as 1, because when our clock signal is 1, D is also 1, then we will get the output whatever D is. So from this position to this position, our output will be 1. From this position to this position, our clock signal is 0, so from this position to this position, we won't care about the input, because whenever our clock signal is 0, we will always get the output as the previous output, and before this position our previous output was 1, so here 1 will continue because here clock signal is 0, and when clock signal is 0, in case of D latch, we will get the previous output as present output. So this was our last previous output, and from this position to this position we have no clock signal, so we will get the previous output, which was 1, as the present output. From this position to this position, our clock signal is 1, so we will get the output whatever D is, and our D is 0 from this position to this position, so we will get the output as 0. From this position to this position, our clock signal is 1, our D is also 1, so we will get the output as 1. From this position to this position, our clock signal is 0, so our last output will continue. From this position to this position, our last output was 1, so it will continue. From this position to this position, our clock signal is 1, our D is 0, so our output will be 0. From this position to this position, our clock signal is 1, our D is also 1, so we will get the output as 1. After this position, we have our clock signal as 0, so our previous output will continue, and as our previous output was 1, it will continue and we will get 1. So this is the timing diagram of D latch. We can construct a D flip-flop using two back-to-back connected D latches. Our main input for the D flip-flop is D1. Clock signal is CLK. Our main outputs for the D flip-flop are QS and Q prime S. Now let's look at the connection diagram. We have connected the output of first D latch to the input of second D latch. We have connected the main clock to the clock signal of first D latch, but we have connected the main clock signal to the clock of second D latch through an inverter. And if we connect like this, we will get the D flip-flop where our main outputs are QS and Q prime S, and our main input is D1. This is our clock. So let's see how we can construct it. Let's look at the timing diagram and see if this circuit is behaving as D flip-flop or not. Okay, let's look at the output of first D latch. So our input is D1 for the first D latch, clock signal is CLK, and our output is QM. So whenever clock signal is 0, our previous output will continue. Let's assume our previous output is 0. That means our previous output will continue. From this position to this position, clock signal is 1, D is 0, so our output will be 0. From this position to this position, clock signal is 1, D is also 1, so our output will be 1. From this position to this position, clock is 0, so our previous output, which was 1, will continue. From this position to this position, our clock signal is 1, D is also 1, so our output will be also 1. From this position to this position, our clock signal is 1, our D is 0, so our output will be 0. From this position to this position, our clock signal is 0, so our previous output will continue. That means previously we had 0, this 0 will continue. Similarly, you can draw the output for the first D latch using the truth table, and if you draw, you will find the timing diagram like this, and we can see this output is connected to the input of second D latch. That means this is D2, and this clock signal is connected through an inverter to the clock of second D latch. That means the clock signal for second D latch will be opposite to the main clock. That means whenever our main clock signal is 0, the clock signal for second D latch will be 1. Whenever our main clock signal is 1, here we will get 0. For 0, we will get 1, 1, 0, 0, 1, like this. So now we can draw the timing diagram of QS using the same truth table of D latch, because now this is another D latch for which our input is D2, our clock signal is clock prime, and our output is QS. So from this position to this position, our clock signal is 1, our D is 0, so our output will be 0. From this position to this position, our clock signal is 0, so our previous output will continue. From this position to this position, our clock signal is 1, D is also 1, so our output will be 1. From this position to this position, our clock signal is 0, so our previous output will continue. From this position to this position, our clock signal is 1, our D is 0, so our output will be 0. From this position to this position, our clock signal is 0, so previous output will continue. And you can complete the drawing using the truth table of D latch. After drawing the timing diagram, you will find something interesting. You will see that this QS is actually depending on the negative edge of this clock. Let's see how. So we are assuming that our initial Q is 0, So we don't have any negative edge of clock signal till this point, so our main output is 0 till this point. But whenever we have got this negative edge, we see that our D is 1, so our output becomes 1. After that we don't have any negative edge till this point, so our output will continue till this point, and at this point our main input is 0, so our output will become 0, and we don't have any negative edge till this point again, so our output will continue till this point. So for D latch, our output was depending on the level of clock signal, but now it is depending on the negative edge of the clock signal. Whenever there is any negative edge, the output will be similar to the input D, otherwise the previous output will continue. Whenever there is a negative edge in the clock signal, we will find the output similar as D, so like this. But whenever there is no negative edge, the previous output will continue like this. Here we have got negative edge, so our output becomes 1, and after this point to this point we don't have any negative edge, and our previous output is continuing. So in this way, using two back-to-back connected D latches, we can construct D flip-flop, where this D flip-flop is depending on the negative edge of the clock signal. So we can say this is our input D1 for the D flip-flop. Our clock signal is CLK. For the D flip-flop, we have two outputs, QS and Q prime S, where we count QS as the main output. So whenever we are getting negative edge, the output will be similar as the input D, but if there is no negative edge, the previous output will continue like this. So here we have our clock signal's negative edge. In this case our input D is 0, so our output will become 0, and after this to this point we don't have any clock signal's negative edge, so our previous output, which was 0, will continue. So that's all for this lecture. See you in the next lecture. Thank you.